Hello, this is Dr. St. John. Today we're starting Chapter 2, Introduction to Optimization and Linear Programming. Anytime we're making decisions, we're faced with limited resources. Time comes to mind right away, so does money. If we're making things, we're usually limited by the amount of raw material that we have available. But there's all sorts of other limitations. Mathematical programming is used to help find the optimal or most efficient way of using those limited resources to achieve an objective, usually maximizing profit or minimizing cost. These are called optimization problems. Optimization problems can be used in places like manufacturing, so for determining how much of different products to manufacture, routing, logistics, financial planning, marketing. There's a whole lot of applications. Basically, if you recall from Chapter 1, if the problem is very structured or semi-structured, then optimization problems work out pretty good. Not so good if they're unstructured. So it's not good for everything, but it's good for a lot of decision making. Optimization problems have a few characteristics. One, they have decisions. We show these by decision variables. So there's some kind of decisions that need to be made. And we make those decisions in the face of numerous constraints, maybe 100 constraints, maybe 500, maybe 5. It depends on the problem. And we have an objective. As I said before, often this objective is to maximize profit. Here's a general form of an optimization problem. Max or min. Sometimes let's say we already have a contract. We're just trying to minimize our costs to fulfill the contract. So it can be a max or a min, profit, cost. And if we're maximizing profit, for instance, it's going to be a function of our decision variables. Our decision variables, if we're making 5 different products, they'll be in terms of those products, how much of each of the 5 to make, and we'll just call those 5, since we want to create this mathematically, write this out mathematical, we'll call them x1, x2, x3, x4, x5, right? Those would be the decision variables. So the general form, the profit is a function of how many of those things we make in that example. Subject to a bunch of constraints. Here, the important thing to see is that the constraints, they are also functions, linear functions, and they're written in terms of the decision variables. So notice it's the same x1s and same x2s. Mathematical format of a linear programming problem. We're maximizing C1, X1 plus C2, X2, and so forth. Well, the C's are the coefficients. So again, if we're making a couple different products, we would call them X1, X2. We could call them something else, but since this is mathematic, we're trying to make it in mathematical format right now. X1s, X2s, those are great. And the C's are the coefficients related to those decision variables. So if product 1 is x1 and product 2 is x2, well, product 1 has some kind of coefficient. If we're maximizing profit, that would be the profit associated with x1. C2 would be the profit associated with x2. Maybe it's $10 and $15, but that's the C1s. Those are the coefficients. And the top one here, that what we're maximizing or minimizing, is called the objective function. That's subject to a number of different constraints, and here's the general format. You'll notice the same again on the left-hand column. You'll see that all the x1s, and in the next column you see all the x2s. So they're all written in terms of the decision variables, but each line would be a different constraint. And this first one you see A1, 1, x1. Well, x1 of course is the first decision variable. A1, the first one refers to the first constraint, and then the second one refers to the first decision variable. So A11 x1 plus A1, the first constraint, still that whole row is the first constraint, 2, which refers to the second decision variable. The next one would be A13 x3. And so forth. It depends on how many decision variables we have. We can have lots of them. That's why we have the dots there. And those constraints, the b's are just the coefficient on the right hand side. That's what it might be. We might be constrained by less than, greater than, equal to. We have to make at least this many, and then that would be a greater than or equal to, or no more than, so that would be equal to, less than, or we need some exact amount, that would be an equal. So the signs can change. The second constraint would be in the format of A2 1 x1 plus A2 2 x2 and so forth. Just so you know what the little subscripts are. It's not, we don't want to make this hard. We want to keep things simple.